What does sklearn, showversions reveal about your scikit-learn environment? A. Versions of all installed Python packages. B. Versions of all installed Python packages used by scikit-learn. C. Versions of all installed Python packages that are dependencies of scikit-learn. D. All of the above. False. This is incorrect because sklearn, showversions is specifically designed to display information related to scikit-learn and its dependencies. Not all installed Python packages. While you might see some overlap with installed packages, the function's primary focus is on those that are relevant to the functioning of scikit-learn. False. This is partially correct because showversions provides information about the core packages within scikit-learn. However, it also reveals the versions of packages that are dependencies, making this option incomplete. False. This is partially correct. Showversions displays the versions of scikit-learn's dependencies, but it also lists the versions of the core scikit-learn packages. It goes beyond just the dependencies. True. This is the correct answer. Showversions reveals the following: versions of all installed Python packages used by scikit-learn. Versions of all installed Python packages that are dependencies of scikit-learn. The specific versions of scikit-learn's packages themselves. It provides a comprehensive overview of the scikit-learn environment and its related packages. D. All of the above. Package management. In essence, it's the process of installing, updating, and removing software packages for your Python environment. This ensures that you have the right tools and components to build and run your applications. Pip. Pip is a popular command line tool used to install, upgrade, and uninstall Python packages. For instance, you can use pip install numpy to install the numpy package for numerical computations. Conda. Conda is another package manager, often used within the Anaconda environment. It allows you to manage both Python packages and the underlying environment, including things like different Python versions. You might use conda install pandas to install the pandas data analysis library. Dependencies. Dependencies are like the ingredients in a recipe. They are packages that other packages rely on to function correctly. For example, a machine learning package like scikit-learn depends on NumPy, SciPy, and other libraries for its core operations. Scikit-learn, NumPy, SciPy, Pandas, Matplotlib. Scikit-learn leverages these dependencies for its core functions, including numerical computations, scientific computing, data manipulation, and visualization. Versioning. Versioning in software is like giving each version of a package a unique identifier. This makes it possible to track changes, manage dependencies, and ensure that different parts of your project are compatible with each other. NumPy 1.23.5. This version of NumPy incorporated new features, bug fixes, and potentially some changes to existing functionality. It's important to keep track of versions to ensure compatibility with other packages you might be using. Reproducibility. Reproducibility is key in science and engineering, and it applies to machine learning as well. It's about ensuring that experiments and analyses can be reliably repeated with the same results. This helps build confidence in your work and allows others to verify your findings. Training a machine learning model. Having a detailed record of all the packages and versions used during training is crucial for reproducibility. If you need to retrain the model later, you can ensure the same environment for consistent results. Collaboration. Collaboration is the art of working together. And in machine learning, it often involves teams sharing code, data sets, and results. To collaborate effectively, Everyone needs to be on the same page, using the same software versions to avoid inconsistencies and confusion. Machine learning team. Before starting a project, the team agrees on the versions of scikit-learn, TensorFlow, PyTorch, or other key packages they will use. This ensures that their code runs smoothly across different team members' environments. Environment management. Environment management is like having separate workspaces for different projects. It allows you to create and manage isolated environments, so each project has the exact packages and versions it needs. This prevents conflicts between different project requirements. Virtual env. VirtualEnv creates isolated virtual environments for your Python projects. This allows you to install packages specifically for a project without affecting other projects or your global Python environment. Conda-env. Conda-env lets you create and manage environments within the Anaconda ecosystem. You can switch between environments for different projects, keeping their dependencies separate. Version conflicts. Version conflicts are like trying to fit a square peg into a round hole. They occur when dependencies have incompatible versions, leading to unexpected errors or incorrect behavior. Imagine trying to run code that depends on NumPy 1.20. But you have NumPy 1.18 installed. This can lead to issues. Package information. Package information is like the metadata associated with a package. It tells you things like its version, author, license, and dependencies. This information is vital for managing packages, resolving conflicts, and understanding how different packages relate to each other. Scikit-learn. Version, author, license, dependencies NumPy, SciPy, etc. This information helps you understand what versions of other packages are required to use. Scikit-learn properly. Troubleshooting. Troubleshooting is like detective work. It involves identifying and resolving problems in your code or environment. When things go wrong, troubleshooting skills are essential for finding the root cause and fixing the issue. Documentation. Documentation is like the instruction manual for your software. It provides written materials that explain how to use a package, what its features are, and how to solve common problems. Good documentation makes it easier for others to understand and use your software. Environment details. Environment details are a snapshot of your Python environment. They include information about installed packages, versions, operating system, and other settings. This information is valuable for reproducibility, troubleshooting, and sharing with others.